Okay, welcome to Kubernetes for liberal arts majors. I'm your host, Gabriel Vega. And I swear to God, my head gets bigger every time I try and record it. Now, one of the simplest things they're ever going to ask you to do is to set up a simple Kubernetes server. Not very hard. You just need to understand the basics. And what you need to understand is this is what a unit of Kubernetes is. A Kubernetes server is, at its smallest unit, at the very least, one worker node and one master node. Now, here's what that means. Node equals computer. Say it with me now. Node equals computer. Now, whenever you hear people throw around the term node, they just mean a computer, not their desktop. Like if I refer to a node on Amazon, I'm referring to a computer on Amazon. A node on Google, that's a computer in Google somewhere. And in order to get these things to work together, you have to do the same thing to all three of them, mostly. So if I had three computers on a desk and I wanted that to work as a Kubernetes server, I would have to take the first computer and install the software and install packages onto it, and then have to repeat that same step for the other two computers. And those packages would be kubeadm, kubelet, and kubectl. But before I did that, I would have to install containerd. Now, containerd is a runtime program. There's a bunch of them. What you're basically doing is you're putting down the foundation and then making the building. So for lack of a better way of expressing it, if you were to make a building and your designs required a concrete foundation, containerd would be the concrete. And kubeadm, kubelet, and kubectl would be the roof, the walls, the doors, the plumbing, all the other stuff inside it that allows it to operate as a functional building. Now, once you do that, you now basically have you now essentially have a cluster. You have a thing that can be defined as a cluster, but it's a little raw. You got to take some additional steps so that it can function on the internet. And what you would do then is you would take one of those computers and make it your master. And what you would do then is you would use kubeadm, which you've already installed on all three, and you would install the control plane. The control plane is responsible essentially for steering the cluster. It's giving your cluster a steering wheel so that you can direct it and tell it what to do. And I'm looking at notes, so if it looks weird, I'm just looking away so I can see what I'm saying. And you now are starting to have, you have a mostly built building now. And it's almost ready to go out and do the work. The problem is it can't talk to other servers and other clusters. It can only talk to itself, sort of. So what you will do next is you will install the Calico Network add-on. The Calico Network add-on creates the basis for networking. Computer A, computer B, computer C still need a little bit of help to talk to each other and to talk to the greater network. You will install the Calico Network add-on to enable that possibility. Next, you have your master, you have your workers, and even though they're all together and they're capable of operating, they still can't quite fully operate as a unit. They need an additional glue to hold them together. And that's when you're going to execute a command that's going to join your worker nodes to your master node. And that will be, and it's kind of weird how they explain it, because they say you're now joining your worker nodes to the cluster. Even though if all you have is a single master node, you technically don't really have a cluster. You need at least the master and the worker nodes to make the cluster exist. And that would be how you would execute putting together a functional cluster to operate in some kind of fashion on the internet. At this point, you now have something that you can get to work on the World Wide Web.